Hi, everyone, and welcome to the Hall Simmer channel. It's good to talk to you guys again. I have changed the schedule, at least for the time being, to Friday evenings because I was finding it difficult to do two streams a week with all the preparation needed and just time limitations right now. So I'm going to shoot for one time a week, and at this point, it will be every Friday evening at 9:30 p.m. Central Time. So hopefully, if you want to watch the stream, you're welcome to join in. Uh, what we're going to do today is we're going to focus on instruments. This is something that we, uh, what we're going to do is we're going to discuss six of the instruments today. We did not start off with this, so in one sense, you might say we are backing up. We talked about other topics before we got to instruments. You could make a case for starting with instruments, but I decided to put a pause on some of the um, actual flying that we've been doing in the Cessna 152 and review, or actually go into further detail on some of these instruments. So, what I want to do this time is I want to focus on the first. There's six instruments I want to talk about, but the first three are going to focus on instruments that the static port and in one case the pitot tube uh, uh, are used to uh, basically provide input to the three instruments out of the six I want to talk about. So what are those three instruments? The airspeed indicator. Well, let me back up. I'm a little bit disjointed today. Forgive me for the disjointed presentation. I'm going to back up and go to the external, go outside the aircraft. And while I'm at it, I'm going to decrease the flaps. There is on the side of the aircraft, and it's right here, there is a static port. Okay. And we're going to be referring to this static port as we look at some images or some graphics that I'm going to show you here in just a minute. But three of the instruments work off of the static port. And then one of the three instruments also works off of this pitot tube, and that's the airspeed indicator. We're going to refer back to this in a bit. But just remember the static port and the line that's going to feed into the instruments from this port. There's a little hole. You can't really see it on the simulator here. I can only zoom in so far, but there's a little hole that would be here. And it's basically going to measure the outside air pressure. And then the pitot tube is going to measure air that is ram air that you might think of it as air that's ramming in to the pitot tube for the airspeed indicator. We'll talk about that, as I said, in the near future. So I am going to return inside the aircraft. And the first one I want to talk about of the three is the altimeter. So that is this instrument right here. I'm going to go ahead and put it off to the right, and then I'm going to pull up a graphic to talk about this instrument just a bit. So I'm waiting for that to show up. There we go. So you'll notice as this graphic shows you some of the mechanics that make the airspeed indicator work. And you'll see to the far left, if you look at that graphic below that says the static port, that is what I was referring to when we were outside the aircraft and I was showing you where that was located. if you follow the line, notice that the line of the static port goes and feeds into a case, okay, sort of an open case. So what is happening here is the static port's taking that measure of the basically sampling the air pressure outside, and that's feeding into the case. And you'll notice that there's aneroid wafers inside the case, and you'll see an arrow that says up and down for those aneroid wafers. So what is going on is as the aircraft climbs, as it goes higher and higher in altitude, the air pressure outside is going to decrease. So the pressure gets less and less the higher you go. Okay. And because the pressure is less, what's going to happen is the aneroid wafer is going to expand because as you go higher, the pressure inside the case is going to decrease. Therefore, the wafer is going to expand. And therefore, your altimeter reading is going to go higher and higher. And you'll notice if you go to the right side of the graphic, you'll see there's a 100-foot pointer, which is the long hand of the clock, so to speak. Then you'll have the 1,000-foot pointer, which is shorter than that. And then you'll have a 10,000-foot little white triangle, which is hard to see perhaps on the graphic. But you can see it if you look at inside the Cessna 172. You can see we're looking at the altimeter from the front, looking at it from the front. And you can see there's a little white triangle that's above the zero. It's that white triangle that's the 10,000-foot pointer. Okay, so we're going to talk about the hands in just a minute, but now you can imagine, so it's going to show a climb as you go higher and higher up because of this aneroid wafer that's expanding. And of course, gears are turning. You'll see there's gears turning, and it has red arrows showing the gears turning. And we talked about this before, but I'll mention it again here. And I would have you refer back to some of the past live streams that I've done where we talk about how important it is to make sure that the barometric pressure is set accurately. So, for example, if the outside barometric pressure is 29.92, which is what it's currently set at, then this would be an accurate reading. And you would have a correct reading of your elevation or your altitude right here. So right now we're at an airport. I forgot the name of the airport, but it really doesn't matter at this point. I just want to point out that right now we are, every little mark you see here is 20 feet, okay? So 20, 40, 60, 80, 100, and so forth. So you see here 20 feet. Okay. So right now we are at about 20 feet or just a little bit under that. And if for some reason the barometric pressure was different, we would have to set this, we would rotate this this knob here, and that allows us to do the calibration. And you'll notice if you look at the window over here on the where it says HG right there, and then you see numbers right there. That's your barometric pressure. And we talked about the fact that that's given when you're listening to, for example, ATIS. And again, refer back to past live streams because I give more detail on that. But it's important to have this accurately set. So if the outside air pressure is, or the outside barometric pressure is 2992, we want to set this at 2992 to have an accurate reading on our altimeter. As we climb, we'll refer back to these hands and we'll show you how this works. This white triangle, let's talk about the shorthand. If the shorthand rotates around to 1, the shorthand is 1,000 feet, okay? So if the shorthand starts rotating, when it reaches 1, it's at 1,000 feet, and when it reaches 2, it's 2,000 feet. When it reaches 3, 3,000 feet. Just like the longhand, the hundreds hand, if it reaches 1, it's 100 feet, 200 feet, 300 feet. And we're going to talk about this again as we climb, because it's easier to see how things work when you climb. Because the Cessna cannot reach 20,000 feet, so this white triangle is 10,000 feet. So if the white triangle were to reach the 1 here, it'd be 10,000 feet, which it can, but the Cessna cannot reach 20,000 feet, so the white triangle's never going to be able to, it just doesn't have enough power to get to 20,000 feet like a jet can, or other aircraft can. So the Cessna 152 is more limited. So, having said that, if you refer back to the graphic, obviously if we're descending, what's going to happen, that static port, referring back to the graphic, is going to pick up the fact that the air pressure is increasing. It's going to feed that through the tube, and that increasing air pressure is going to decrease the wafer, and so therefore it's going to contract, and the hands are going to reverse and go counterclockwise, and we'll be in a descent. So it's interesting to see how this works. Now, what I want to do is take off so that we can see this in action. So I'm going to do that, and but first I'm going to take off the graphic. So that we can see. All right, now I'm going to go ahead and take off. And keep in mind, right now we're at about 20 feet. Before we take off, one thing I forgot to mention is I picked an airport that's near sea level, so that we could start from almost like we were just barely above the water, about 20 feet above sea level. And that's why I picked this airport. So I am going to remove the parking brake, which I always manage to forget to do. Oops, that's the flaps. This is the parking brake. So the parking brake is over here. And I'm releasing that so that we can take off. And I'm going to add power. And here we go. Going to rotate about, I'll just roughly rotate about 55 knots. And I'm just going to try to climb slowly so that we can zoom in. Now you see how the altimeter, and hopefully I don't hit a tree as I'm talking to you, you'll see how the altimeter is rotating counterclockwise. And look at the long hand. And right now we are at 200 feet, 220, 240, 260, 280, 300 feet, okay? 320, 340, 360, I'm climbing a little fast, 380, 400 feet. And it's kind of hard because I'm trying to talk to you and fly at the same time, like chewing gum and walking again. Okay, now 480 feet, 500. Notice that this hand, which measures 1,000 feet, is halfway because we're just past 500 feet. And so And as we climb, the shorthand here is going to approach 1,000. So right now we are at about 750 feet. Now we are at 800, 820, 840, 860, 880, 900. As soon as we reach 1,000, or we get to the zero here with this hand, we are at 1,000 feet. Notice this is pointing to the 1. Now we're going 1,100 feet, right? 1,020, 120, 1,160, and so forth. So we see the hundreds hand is going around the thousands. And what will happen is we will, let me back off here, we will reach, let's just say 1,000 and 1,500 feet. And then what I'm going to do is descend so that you can see it go counterclockwise. So now I'm going to back off the power to descend a bit. I'm going to try not to descend too fast. But I do want to descend, so notice now, as we start to descend, which we aren't descending just yet, we're flying level. Let me back the power up just a little bit more. Okay. Let's see where we... Okay, I want to descend just a little more. And you see now we're starting to descend, and so it's going counterclockwise. So we're at 1,500. It's hard to go backwards. 1140. Because we're at we're at above 1,000. Now we're at 1,400. Descending to 1,300 feet. And we see that the hundreds hand, which is still above 1,000, now we're at 1,200. Oops, climbing a little bit. Oh, I'm turning too. Wow. See, I'm not paying attention to the other instruments. So now I'm climbing big time. What I need to do is back this off so I can see a little bit. All right. Hopefully you can see this. 1,200. 1,100. And notice the thousands hand now reads, as we continue to descend, 1,000. And now it'll fall below the 1 as we start to approach 900 feet and so forth. So hopefully you get the idea of how to read the altimeter and how that works. And again, the accuracy, you have to, when you're flying, as the atmosphere changes and the pressure changes, you have to periodically reset this, recalibrate, to make sure that your altitude is accurate. So this is the altimeter, which is one of the instruments that works off the static port. And now I'm going to temporarily pause this and go to the next one, which is the vertical speed indicator. This also works off of the static port. And I'm just waiting for it to pull up. So as you can see, this also has one of those wafers in it, okay? But notice that the one thing I want you to notice is that there are 2 feeds from the static port on the outside of the aircraft. You have the direct static pressure. Notice it's feeding right into the wafer this time instead of into the case. Okay, it's feeding into the wafer. So, and then you have a calibrated leak that is also feeding from the static port. So the static port is feeding into two areas, the calibrated leak at the side of the case and also directly into the wafer. So what's happening here is, let's say you're climbing in this example. When you climb, again, remember that the air pressure decreases. And so what's going to happen, because that direct static pressure is feeding into the wafer, it's going to immediately contract initially. And then, but because the calibrated leak, what it does is it causes a delay in the escape of air pressure in the case. So what happens is the air pressure in the case is higher than the air pressure in the wafer, so it helps to further squeeze the wafer, which then uh, causes that decrease to go on and will indicate a climb. And then the opposite happens when you're descending. So what happens when you're descending? The air pressure increases. That is going to feed into the direct static pressure line from the static port. It's going to go into the wafer. The wafer is going to expand at that point. And then what's going to happen, there's going to be a delay again, so that what happens is the air pressure in the case itself, because of the delay with the calibrated leak, the case itself is going to have pressure that is less than the wafer, than what's within the wafer, because it gets a more immediate read of the static port, reacts more immediately. And so it's going to help continue to encourage the expanding of the wafer, which again is going to uh, basically going to show that descent taking place. So that's how the vertical speed indicator works. And you can see that, again, there are gears in play that as that wafer is expanding and contracting, uh, you see like a red arrow twisting that's showing a bar that's going to twist the gears, and that's going to control the vertical speed indicator. So if we go back to, and I'm going to go ahead and clear the graphic. And so if we go back inside of the aircraft, I'm going to just try to zoom in a little. This is the vertical speed indicator, and you see the needle going up and down. So if the plane is climbing, if the plane is flying level and it's not climbing or descending, then you're going to be right on the zero right here. Okay. So if I'm not climbing or I'm not descending, I'll be on the zero. But if I'm climbing, I could be climbing 100 feet a minute, 200 feet a minute, 300 feet a minute, 400, 500 feet a minute, and then, continue to count up 600 feet, 700 feet. Add some power here so I don't crash. I'm stalling. So, about 23. So you climb 1,000 feet a minute here and 1,500 feet a minute here and 2,000 feet a minute here. So right now I'm climbing about 600 feet a minute, 500 feet there, and it can be a trick because I'm zoomed in. It's a little tough to control the aircraft, but now I'm climbing about 800 feet a minute, and now it's dropping 500 feet there, 400, 300, Well, you can imagine below the zero, it's just the opposite, right? So now I'm descending 100 feet, 200 feet, 300 feet, 400 feet. And then if I push the yoke forward here, 500 feet, and maybe I can ease off power as well to help with that. But you get the idea. You're going to be descending, and again, it's going to show you how many feet per minute you're descending. So 500 feet per minute, and then if I go further down, that's 1,000 right there, and then you got 1,500 feet, and then 2,000. So that is the vertical speed indicator, and in a nutshell, how it works. And again, the static port is used to make the reading. The third instrument we talked about in detail in a past stream or two, past live stream, and that is the airspeed indicator, which is right here. So zoom in a little bit. It's this guy. And what I would encourage you to do is take a look at those past streams to see the discussion that I had on the airspeed indicator. What I want to do is pause this just a second. Actually, I'm going to keep flying. Go outside the aircraft. This is the one that not only, oops, not only works off of the static port right here, but it also works off of the pitot tube right here as air is ramming into the pitot tube. So I am going to go back inside the plane and hit escape for just a second and pull up the next graphic so you can see this. So there it is. And you can see how in the graphic that you see that the what's called the ram air, which is basically the air that's being forced in as you fly through the air in the aircraft, that's called ram air, and it's going to feed into the pitot tube. And then uh, as you increase your airspeed, you'll have more ram air feeding in, and your wafer, or the diaphragm as they call it here, will expand. As you decrease your airspeed, it will decrease, and that's what the arrows are showing you right there. And then what it will do is, based on that, what's happening, you'll see also, in addition to the pitot tube, that there is the static airline, as we discussed, on the outside of the airplane, is feeding into this instrument as well. And what is going to happen is your airspeed is going to be calculated as a result of the difference between the ram air that's coming in from the pitot tube and the static air that is coming in from the static port. And it's going to take that difference and calculate an airspeed for you, which you will see on the airspeed indicator. So we have those first three instruments that work off of, all three of them work off of the static line, the static port, and then one of them, the airspeed indicator, also works off of the pitot tube. And it's one of the reasons when we talked in the past on the stream, as we were discussing, as you're doing your walk around the aircraft, your pre-flight inspection, you want to make sure that none of those are blocked, because if you got something in the pitot tube or something in the static airline, then you're not going to get accurate readings off of your instruments. So it's important to do that pre-flight inspection to make sure that those are clear. And that you're getting therefore an accurate reading. So that's the first three. Now the next three instruments that we're going to talk about. So what I'm going to do is I'm going to temporarily take off the graphic. And then I'm going to reload the flight from ground. So I'm going to load it up again. So that I can show you the three instruments we're going to talk about next. And as this is loading, the three instruments, here we go, the three instruments we're going to talk about all work off of gyros. So if you think of a spinning top, for example, you know that when you spin a top on the ground or on a table, as that top is spinning really fast, it maintains a rigidity to the airspace around it. So it tends to stay in that that horizontal plane, I guess you could say. As it's spinning around, it doesn't topple over. When it starts to slow down, that top gets wobbly, and then it eventually just dies out and falls over. So that rigidity in space is the principle that is used for the next three instruments. It's the same thing as if you're riding a bicycle. The faster the tires are spinning, they tend to hold themselves up. Again, maintaining that rigidity in space. But if you start to slow the bike down, then you start to wobble. And if you don't put your legs down, then obviously the bike is going to tip over. So the three instruments that work off of gyros are the attitude indicator, which is right. Let me zoom in. This is the attitude indicator. And then we have let me get rid of the yoke for just a second. We have the turn coordinator right here. And then we have the heading indicator showing which direction we're going right here. These three instruments work off of gyros. And when you start your aircraft, when you're going through the start engine procedure, which I want to encourage you to look at the past streams because we talked about the engine startup. When we start up the aircraft, you can hear you can hear the gyros start even before. I think we were doing it in the pre-flight inspection. One of the steps, when you turn on your battery, for example, I think they start to spin then. But you'll hear these sounds, and that's the gyros spinning. Two of the gyros, which I believe is the attitude indicator, if I remember right, and the heading indicator, work off of a vacuum. So you got a vacuum that's suctioning air across the gyros, and it causes those gyros to spin really fast. And that's why you have this suction gauge, and why you want to make sure your suction's working, because if your gyros are not spinning fast enough, you will get an accurate reading off of your instruments. And then for the turn coordinator, the gyro works off of electricity, so DC electric here. So it has a gyro too, but it's working off of electricity versus off of vacuum. So that's how those three are controlled through the principle of using gyros and rigidity in space. So what I want to do is start off with the turn coordinator. I'm going to try to zoom here like this. And then I'm going to go back and find the graphic for that. And it's going to come up here in just a second. Okay, there it is. So, as we look at this, you'll see the pink spinning gyro. And you'll see gimbals on each of the instruments, each of the three instruments we're going to talk about. Those gimbals help basically allow the spinning gyro to maintain its rigidity in space. And you'll notice in this case, as the plane rolls about at axis, the gyro is going to maintain its, in this case, we can see it's kind of a vertical position. And so what happens, for example, as we see in this particular graphic, that as we turn, for example, the plane to the right, the gyro is going to look like it's turning to the left, but it's just maintaining the vertical position in space. And so you'll see there's some gears there. So what's happening is it shows that gear turning counterclockwise. You see an arrow there around a shaft that's coming from the, looks like it's attached to the, maybe the gimbal. And it's spinning, it's turning counterclockwise, which is connected to yet another gear that's going to turn clockwise and therefore turn, because we're making a right turn, it's going to turn the symbol of the aircraft to the right. So you'll see that there's two lines of the turn coordinator. And right now I'm going to remove this graphic. So let me go ahead and do that. I'm going to find that. Okay, so it should disappear here in just a few seconds. So what I'm going to do, I'm actually going to load, because I want to get up in the air fast. I'm going to see if I can find one of the flights where I'm just up in the air already. So let's do, see if I can find one that is, maybe this one. There is something called a, as this is pulling up, there's something called a standard rate turn, which means that you would be turning your aircraft roughly 3 degrees per second. And since there's 360 degrees at a circle, that means that you would be completing your turn in 2 minutes. Okay, so there's this turn coordinator, which I'm going to remove this. The turn coordinator here, this line here is a standard rate. Notice it says 2 minutes. This is a standard rate right turn, and over here is the standard rate left turn right here. And if you can keep your wings on these right here on this mark, as if I'm doing a standard rate right turn, you will complete the circle in 2 minutes, because again, you are turning at 3 degrees per second. So if I was to, let me see if I can back this up a little bit. If I was to turn, you'll notice the wing drops, and if I could hold it there, right there, a little bit past it, right there, that is a standard rate turn, and I'm turning at 3 degrees in a second. Right there. So it will take me 2 minutes. Again, because there's 360 degrees. So 360 divided by 3 is 120. 120 seconds is 2 minutes. And that's where you get the 2 minutes. And Again, that's where you're doing a standard rate turn to the right in this case, or if we go the opposite way, then you're doing a standard rate turn. Oops, a little too far. Standard rate turn to the left. Right there. Let's see if I can get that noise down from the marker. There we go. So I'm doing a standard rate turn to the left here. So it would take me 2 minutes to complete the 360-degree turn by doing that. So that is how the turn coordinator works. And I'll give you a feel for that. Of course, now we're wings level, and I'm going to pause it. All right, the next instrument that works off of gyros is the heading indicator. And we talked about this instrument as well, and we've referenced it in a past stream or two. And so I want to talk about it again. I'm going to find the heading indicator graphic and pull that up. And waiting for it to pop up here. There we go. All right, now you'll see that there are gimbals that, once again, you see that if you look at the gyro where it has the arrow pointing to the gyro, you see that it's vertical pretty much, and that the gimbals allow that gyro to maintain rigidity in space, as we've been talking about. And then there is a combination of gears that you see going across over to the compass card that we see as we're looking at the instrument. What that basically does, those series of gears help to maintain alignment with the with the gyro, so that you get an accurate reading of your current heading. Okay, so if I go ahead and remove that, just wanted you to see that we do have a spinning gyro in this instrument as well. So I'm going to actually take this off now. And that should disappear. And what I'm going to do is, once it disappears, I'm going to go back inside the aircraft. So I'm going to resume here. So this right here is the heading indicator. Now sometimes it can get off just because of the gears, the friction of the gears. Also, as you travel long distances, it can get off with because of the way the magnetic field is on the Earth. And you may have to adjust it periodically from time to time. And what you'll do is you'll fly straight and level and make sure it's lined up with the compass up here at the top of the window. So right now, it looks pretty much lined up with the compass, but you may have to calibrate it, and you would do that by spinning this knob here to make sure that the compass is in alignment. We talked about how you have 360 degrees in a circle, right? And north is 360, and if the N wasn't there, you would see a 3/6. We also talked about how this also corresponds with the runway that you are facing. So if I was at an airport and I was at the end of the runway, I would be on runway 36, for example. We again refer to the streams that we did in the past. And you'll notice if I zoom into the heading indicator, if there's a mark, there's a 5-degree mark that's a smaller mark, and then 10 degrees right here. So you have a mark every 5 degrees, but it's right now it's 5 degrees, then 10 degrees, 15, and then 20, 25, and then you see 3 is 30. So keep in mind that the trailing 0 is removed always from the heading indicator, so you don't see 30, you just see 3. And keep that in mind for your runways as well. You'll see runway 3, but it's really 30 degrees. So you're really at this point facing northeast or north-northeast right here. And then, of course, if I was to keep turning, 50 degrees, 60 degrees, 70. East is 90 degrees. South over here is 180 degrees. West is 270 degrees. North, again, is 360. Or 0, but 360 is fine. And that is your heading indicator. And, of course, we're going to be using this as we navigate and as we land and take off and all that. So the heading indicator is very important, a very important instrument, but is also one of those instruments that's controlled by a gyro. So we are going to hit escape, and we'll talk about the third and final instrument that is controlled by a gyro, and that is the attitude indicator. So I'm going to find that graphic and pull it up. And you'll see here that this one is more of a horizontal gyro that maintains rigidity in space. And it will pitch, it will not only roll as you turn, so you got a roll gimbal, and then you also have a pitch gimbal because the instrument also will indicate pitch as we talked about pitch, we talked about roll, we talked about yaw, again referred to a past live stream we did. But so as you're turning the aircraft right or left, that's rolling the aircraft. As you're pulling on the yoke or pushing forward on the yoke, you're pitching the nose down or up, that's pitch. And so anyway, the attitude indicator is the instrument that's going to show that. And again, because of the rigidity and space principle, it's going to, the gyro's pretty much going to maintain that angle in space as you pitch up and down and as you roll about the axes of your aircraft. And so they have both the pitch gimbal and the roll gimbal to allow the gyro to maintain that rigidity in space that we've been talking about. So let's talk about the attitude indicator. What I'm going to do is go back inside the aircraft. And I'm going to resume flight. Now, and I'm hopefully not going to crash. I'm going to back this up right here so I can see a little more. Okay. So let me zoom in here. So first of all, you have these markers. So right now you'll notice this orange bug or this marker right here indicates that we are pretty much, we're not doing a turn. Okay, we are, well, let me back off and say that this is an artificial horizon. The brown part represents the ground, is it the earth, okay, and how we are in relation to the earth. So as we start to turn, you'll see the earth banks as well, and this stays even with the horizon of the earth. And then we have the blue, which is the sky portion, and then this represents the nose of our aircraft and the wings, you know, and how we are in relation to our attitude, our position in relation to the earth. So we have these markings right here. This is a 10-degree turn to the right. So if I go this way right here and go on that mark, I'm turning 10 degrees like that. This is a 20-degree turn, like so. This is a 30-degree turn, so you see my bank, let me back this off, is steeper. And then we have a 60-degree turn right here, and then 90 right here. Same thing for the left side, 10-degree, left turn I should say, 10-degree, 20-degree, 30-degree, and then 60 over here. Now, there are two other, we do have a 15-degree, or is it 10-degree? Maybe it's 10 and 20 because they have 10 and 20 here. Oh no, that's pitch, I'm sorry. So, through myself. So right here, you see this white line right there that I have the wing on? That's a 15-degree. I'm doing a 15-degree left turn right there. So that's 15 degrees. That gets that one. And then right here, this one is a 45. I'm going to try to get there and hopefully not crash. This is a 45-degree turn right there. That's that white line. So I'm doing a 45-degree left turn. Now get out of that. Same thing for this side. We got a 15-degree right turn, and we have a 45-degree right turn. And then notice we also, in the attitude indicator, let me zoom in, we have pitch as well. So as we get that, right now we're at 0 degrees of pitch right here. As we move the nose up, we have 5-degree pitch right here. That's that first line. Then we have 10-degree pitch right there. 15-degree pitch. We're pitching up. We're nose up. 15-degree pitch. And then 20-degree nose up pitch. Oops. And we're stalling because we're going too high there. So 20-degree. Then, let me add some power here. Actually, I'm going to decrease power. It'll make it easier to make sure I'm high enough. We are at 0 degrees of pitch. Now, if we are descending or pitching, I should say pitching our nose down, we have, don't we have any markers for the 5-degree, but we have the 10-degree, and then we have, and I'm going to pull up here, we have the 20 right there, and I'm going to pull up because I don't want to crash into the earth. And those are the pitch degrees of the attitude indicator. And sometimes it can get off as well, and you could calibrate it with this knob. So that's the other gyros. So we've covered the 3 gyro instruments, and that gives you a taste of the 6 instruments that we are going to use for flight, and hopefully that is illuminating and you are able to take that and use that and become familiar with these instruments. Of course, there's plenty. I did want to mention that on some of these graphics that I used tonight, there is a Learn to Fly blog. It's learntoflyblog altogether.com. No spaces, learntoflyblog.com. Some of the graphics came from there, if not most of them. And I recommend that if you want to add to your knowledge of flying, that's yet another resource. And I have a ton of resources listed on the channel under the About section. So if you go there, you'll see a lot of resources that you might find handy as you're learning to fly. And in our case, we're learning to fly with the Cessna 152, which is what we've been doing. And we're going to continue to stay with this aircraft because on next Friday, we're going to start talking about flight fundamentals in our next stream. And so we're going to go there and cover some things that we also skipped And then we're going to get into some real interesting fundamentals that you'll like as we do climbs, as we do descents, as we fly straight and level, as we change airspeeds. We're going to do some of that on the next stream, which would be the following Friday. So I hope you found this helpful. I'm looking forward to that very much, and I do appreciate your time. And I hope you all have a wonderful rest of the weekend, and we will talk to you again soon.